Think big. This is something what you have heard many times before in association with personal growth and self-improvement. But in my talk, I'm going to encourage you to go directly the opposite way. So, think small. Think really, really small. But first, let's think about how small is too small. Of course, it depends on discipline or topic we are speaking about. If you are selecting a family car for all your kids, then 3 meters would be too small. But when speaking about biological disciplines, then millimeters, micrometers would be too small for common observation. Let me give you one example. A tardigrade, so-called water bear. In my opinion, this creature is a superhero because this organism is able to survive in boiling water. It's able to survive freezing down to absolute zero. And it was even able to survive 10 days in cosmic environment and repaired its damaged DNA. And this creature has size of 1 millimeter on average. And it's 1 million nanometers, in fact. So compared to chemical systems, for instance, water molecule is below 1 nanometer in size. So then this superhero, water bear, is barely visible to the naked eye. Let me give you another example related to a human body, a human hair. Human hair, compared to pollen grains, which are down to several microns in size, and nanofibers, is also a huge object. So you see that size is a relative thing. And to help you imagine how big 1 nanometer is, one study has estimated growth rate of human nails. And they found out that our nails grow approximately 1 nanometer per second. So it's 1 nanometer, 1 nanometer, 1 nanometer. So when you take a look on your nails, you see that you don't see anything. So then, nanoscale is in fact not visible with the naked eye. But what is visible is their color manifestation. In nature, commonly a color is given by presence of some chemical pigment. And this chemical pigment reflects given component of visible light, and therefore we see that given color. But there are some cases when no chemical pigments are present, and despite that, we can perceive some color. This butterfly is a nice example of this phenomenon. No chemical pigment present, but we see the blue color. And it's given by presence of specific nanostructures on surface of these wings of this butterfly, which causes light diffraction and reflection of blue component of visible light. Many times I tell my students that nature is the best engineer. And this principle was also inspiration to several technological solutions we are using, you are using. And for instance, on banknotes, those security features, holograms on credit card banknotes works on same principle as wings of this butterfly. Another example, migration of animals. Have you ever thought how migratory birds are able to find their way from southern Africa to northern Europe? How do they do this? Or how a honeybee or a bumblebee can find their way back to their home, beehive, or nest when flying away several kilometers. Nanoscience has helped us to reveal this principle, and it is given by presence of specific magnetic nanostructures or nanoparticles somewhere in their body, in their eye, beak in case of birds, so in several parts. And these nanostructures, magnetic nanostructures, work in fact as a compass needle, which helps them to perceive magnetic field and to get oriented using this magnetoreception. And also this phenomenon is same as design and develop magnetic nanofluids we are using, which could be also used for instance, for targeted drug delivery. But nanomaterials, various products of nanotechnologies, are not only present in nature, but thanks to a huge development in nanotechnologies, you can find them in various aspects of human activities. Let's imagine you are traveling on a vacation by plane. You get to a hotel, check in their electronic system. Then you are heading to beach or swimming pool. You will not forget anti-scratching or scratch-resistant sunglasses. You will not forget anti-wrinkle dress or stain-resistant t-shirt. Of course, you will grab a sunscreen and a cell phone to listen to some music. And in all these items, various products of nanotechnology could be present, in fact. But it's not only about these applications. There are also several advanced nanomaterials, several advanced applications which could help us as mankind to solve several critical issues we are facing now as a climate change. So nanomaterials for energy storage, nanomaterials for greenhouse gases capturing, but also nanomaterials which could help us to solve antibiotic resistance. So you see that nanotechnology is a game changer these days. But this game changer has, or could have, two sides of the same coin. One side is nice, shiny, and we can see all the ornaments on its surface pretty clearly, while the other side could be completely different. What does that mean? Not that it's not that nice, but what's most important, we cannot clearly see what are the environmental and health risks related to release of these nanomaterials into the environment and entering these nanomaterials into our body, organism of any biosystem. We can say that nanomaterials could be good servants, but bad masters. And it's up to us which side will prevail. And since this conference is entitled Breaking Barriers, let's think about what a barrier means. Of course, several colleagues mentioned that barriers could be something which we want to get rid of, especially when speaking about personal growth or gender topics. But a barrier could be also something what protects us, what we need. And in this case, a barrier is a biomembrane which protects cells against ambient environment. And nanoparticles are known to be able of penetrating inside a human body. And once they enter our bloodstream, they could be hitchhiking, so-called hitchhiking, red blood cells. And then they could be translocated anywhere within the organism. And what we don't know, what are the target tissues, what are the target organs, most important thing, what are the effects on our health. And my team, our team, research team, which I'm proud of, has studied presence of solid particles in various human tissues and body fluids. And for instance, we've detected solid particles in amniotic fluid. What does that mean? Solid particles were present in a body fluid where an unborn baby is. So this fetus could be exposed to these particles. So it means that these particles were able to pass through another barrier, which is placenta, which works as a filter, in fact. So that's why we have to raise awareness. We have to be careful when releasing some nanoparticles into the environment, because we don't know where they may end up. And you may ask how braking of automobiles is related to breaking barriers. This is another field of research we are doing. Each time you press brake pedal, you are generating wear particles. That's what we already know. What we also know, that these particles could be down to several tens of nanometers in size. And also these particles could eventually enter our bloodstream and end up in any organism of our body. So the challenge for us as material scientists and material engineers is to come up with a solution how to design new eco-friendly materials for brake pads and brake discs to minimize these emissions. And we can do that. So this is not something which we cannot do. Better safe than sorry. Since we don't know what are the effects, there is a strategy recommended when dealing with nanoparticles being released into the environment. So since we don't know what are the effects, it's better not to, for instance, expose kids to these nanoparticles, which are being, in some cases, applied on purpose. That's that mention about kindergartens, where these persistent inorganic nanoparticles, in some cases, were used. And the best situation when speaking about safety, in my opinion, is currently in automotive sector. When you realize that manufacturers of automobiles have many ways how to minimize risks, airbags, seat belts, crash zones, and many, many others. And also users, it means drivers, are taught how to follow traffic rules, not to drink and drive, and many, many aspects how to minimize risks. And that's something what we are still missing in the field of nanosafety and applications of nanomaterials. And since industry is the key player in this field, when speaking about nanomaterials which are being generated unintentionally as byproducts of braking, for instance, as I mentioned, or industry which is manufacturing and producing nanoparticles, synthetic, so on purpose. And what they can do to minimize these risks. There's a pretty smart strategy called development of materials safe by design. So there is also a way how to deal with that. Not to let nanoparticles be released unattached to the atmosphere, for instance, but attach them to some carrier, to some matrix, but keep their unique properties we need. So this is one thing. And another thing is to act responsibly, also within sustainability, which is a pretty important goal of entire society. And what you can do to protect yourself when speaking about exposure to nanomaterials, where you can face them in face masks, you can face them in various cosmetic products. So one thing is ask for more information, increase your knowledge, so be more informed about what you are using, in fact. And what else you can do is to get that knowledge, which in fact could be free or should be free, since there's open science and everything should be accessible. But in fact, knowledge is not free. You have to pay attention. And I do thank you for paying yours during my talk. Thank you.